Chemical properties of amines has us talking about the reactions that amines can go through. So we will talk about how amines can act as weak bases, and we'll also talk about a neutralization reaction, which we will find out is important for creating water-soluble drugs. Right, so our amines have a lone pair of electrons, which means they are going to act as weak bases. And according to our Bronsted-Lowry definition of bases, that means that they're going to be proton acceptors. So down below, we are seeing an example of ammonia in water. Now remember that water is called a substance that is amphoteric, which means it can act both as an acid or as a base depending upon what's in it. So in this case, we have ammonia in water, and ammonia is a weak base, so it's going to accept a proton from water, which is acting as an acid in this case. So our proton from water is going to be donated, and it's going to be donated right in that position of those lone pair of electrons. When you add a fourth proton to nitrogen, it takes on a positive charge due to that extra proton in there, and it then becomes the ammonium ion. And if you remember back from 1201, we talked about this as being a polyatomic ion. What you also form is a hydroxide ion. Notice that these both have charges. So the appropriate way to show that my ammonia has taken on a positive charge and has become the ammonium ion, and remember that ion means charge, is to put these brackets around it and to put the charge right outside of that, and that'll become important for our next reaction. In a neutralization reaction, we're going to take an amine and we're going to react it with an acid to form an ammonium salt. So the point of doing this, and this is important for medicine, is we want to take an amine that may or may not be water soluble already, and we want to make it more water soluble by creating an ammonium salt. So it's a way to take an amine that may not be water soluble, make it more soluble. This is called your solubility switch. So adding the acid makes a salt that is more water soluble. And this is important in drugs that are used in humans because we are mostly water. We would like water soluble drugs. Those are more effective. So let's start by naming this. We have a single methyl group on an amine. So this is methylamine, and methylamine is reacting with hydrochloric acid. So Bronsted-Lowry definition tells us that the proton is going to be donated from the acid to the base. So that lone pair on the amine is going to accept the proton because it's a weak base, just like we saw on the last slide. When this happens, we have to put our brackets on because now we have an ammonium ion and it has a charge. Our salt also has a charge. We have formed a cation, the positively charged ammonium, and we have formed an anion, the chloride in this case. So your textbook is going to show ammonium salts just the way it's written here. Your lab manual will separate these with a plus sign. Either way is okay. I don't care how you show it. They are saying essentially the same thing. Let's try naming this now. So we have a single methyl group coming off of our amine, so we're going to name that the same way. So this is still methyl, but instead of being methylamine, we've now created an ammonium ion. So we're going to call this methyl ammonium, and we are going to name the anion with an IDE ending. So chlorine becomes chloride. And this will be important to know how to do. We're not going to get crazy or complex with these, but you should know how to name a simple ammonium salt. All right, now it's your turn to practice. What I would recommend is trying this problem on your own, pausing me, and then checking back in to see what the answer is. I also highly recommend that you try naming both IUPAC and common name for that reactant. Okie dokie. So for your IUPAC name, we are naming those groups with a nitrogen coming off of the parent chain. This seems a little bit silly in that all of my groups are methyl, but we're going to go through the exercise anyway. Okay, so I get to pick any of these to be my parent chain. So methanamine is my parent, And I'm going to name the other two groups as branches. So they would be N dimethyl methanamine. If I were to name this using the common naming system, it's a lot easier. I just call this trimethylamine, and now we are seeing why we prefer to use the common naming system over the IUPAC for this. All right, so we should have donated our proton to the amine, forming an ammonium ion. To name this, we are going to name the groups coming off of the amine. So this is trimethyl. And again, this is an ammonium now instead of an amine, so I just say ammonium chloride. And we're done.